Yeah, good evening, children. Good evening, online students. Shreya and Lakshana, good evening. Yeah, I've shared my screen. Is it visible to the online students?
Yes, ma'am.
Yeah. So we're almost done with the first chapter, number systems. So we just have a small portion which involves constructions. Since we have a few new students in the class today, I'm, going to the second chapter, polynomials. So I'll tell you when we will do constructions of number systems. I'll let you know. All right. Yeah, only that part has to be done. The rest of number systems have been covered in detail. All right. Yeah. So this is the second chapter in your NCRT maths textbook, polynomials. And now we'll take the introduction to this chapter. So we'll recall the terms from the scratch, starting from constants, variables, and then algebraic expressions. And then we'll understand what the name of the chapter means. What are polynomials? All right, the chapter is called polynomials. Can I have your attention? Okay, the name of the chapter is polynomials. So before we directly understand what polynomials are, we'll go back to the terms constants, variables, algebraic expressions, and then understand what polynomials are. All right. So what is a constant? A constant is a symbol that assumes or that takes a fixed numerical value, right? A constant is a symbol that takes or that assumes a fixed numerical value. So we say 10 is a constant because 10 is 10. 10 is a constant. See, 10 is a symbol. It's a symbol. Symbol meaning a kind of drawing. It's a symbol, right? It's not a text. All right. Something which is drawn, like, see, you might say this is a text. I'm saying like something which is drawn is a symbol. Now, this, when you write something like this, you call this symbol X. You read it as X. Yeah. So 10 is a constant because this symbol is a fixed value. 10 is 10, right? What is a variable? What is a variable? A variable is also a symbol that can assume or that can take any numerical value. Come. Good evening. Yeah. You can sit here or you can sit there. You can sit in the first bench or you can take the second bench there. Yeah, fine. Wherever you're convenient. Yeah. So both constants and variables are symbols. All right. A constant is a symbol that takes a fixed numerical value or that assumes a fixed numerical value. A variable is a symbol that takes or that assumes any value, any numerical value. Right? Now, a combination of constants and variables connected by some or all mathematical operations is called an algebraic expression. All right. What is an algebraic expression? An algebraic expression is a combination of constants and variables. Now we know what constants and variables are. So an algebraic expression is a combination of constants and variables connected by some or all mathematical operations. So we know we have 4 mathematical operations: addition, subtraction, multiplication, and division. All right. So quickly again, a constant is a symbol. A variable is also a symbol. All right. A constant is a symbol that assumes a fixed numerical value. A variable is a symbol that can assume any numerical value. Don't get distracted. Look at me. Concentrate on what I'm trying to convey. Now, so after understanding the terms constants and variables, we can understand this term algebraic expression. So an algebraic expression is a combination of constants and variables connected by some mathematical operations or all mathematical operations. All right. The introduction part, the theory, and everything that pertains to the introduction part will be shared with you on WhatsApp. So you have Saturday, Sunday, Monday to complete the notes. So you don't have to write anything now. All this will be shared with you on WhatsApp. You can complete this. You should complete this before you come to the next class on Tuesday. Is that fine? Constants, variables, algebraic expression. All right. Now, terms of an algebraic expression. Before that, we'll just see we'll see the terms first because I have that in my slide here. So terms of an algebraic expression. Now, how do you identify or how do you make out the terms of an algebraic expression? So terms are separated by a plus or a minus sign, not multiplication, division. But we have 4 mathematical operations. Forget multiplication and division. Terms of an algebraic expression are separated by a plus sign or a minus sign. Terms of an algebraic expression are separated by a plus sign or a minus sign, not multiplication, division. So if you consider this example ABCD, okay, now ABCD is an algebraic expression because it's made up of variables A, B, C, and D. So it's not mandatory that there should be a constant also. It's not mandatory. It's not that there should be a constant. You cannot ask me like, where is the constant here? It's okay. This is an algebraic expression. Okay, you may or may not have the constant there. So it can be like this, or even if this part is not there, it's still an algebraic expression. So ABCD is an algebraic expression. Okay, and it's an algebraic expression having 4 different variables, A, B, C, and D. Now, how many terms does this algebraic expression have? How many terms? Okay, so it's not A, B, C, D, 4 terms, because what is A, B, C, D? It is A into B into C into D. Multiplication and division are not separators. Multiplication sign and division sign are not separators. Okay, so you cannot consider this one as a separator. So it's not 1, 2, 3, 4 terms. It is not 1, 2, 3, 4 terms. It's only one term. ABCD is only one term. ABCD is only one term because you don't see the separator plus or the minus sign. That's it. But if I write A plus B minus CD, how many separators we have? See, this one is a separator, this one is a separator. So this is one term, this is another term, this is another term. So this algebraic expression has 3 terms. ABCD is an algebraic expression with only one term because there is no plus minus separator. So that's only one term. ABCD is one term. But if we take this example, A plus B minus CD, plus is a separator, minus is also a separator. So now count the terms 1, 2, 3. CD is one term because C into D. Multiplication is not a separator. So CD is only one term. So 1, 2, 3 terms. So terms of an algebraic expression are separated by the plus sign or the minus sign. Is that fine? Not multiplication or division. So A by B, the expression A by B is an algebraic expression. The expression A by B is an algebraic expression containing only one term. A by B, only one term, that is because division is not a separator. A by B is only one term. AB is also only one term. Is that fine? Okay, so that's about terms of an algebraic expression. Now see the examples here. Just have a look at the examples. So in the first example, how many variables do you see? 3, 2 variables. Okay, in the first example, we see 2 variables. Online children, my screen is clear. Am I audible?
Yes, ma'am.
Very nice. Okay, so in the first example, how many variables do we see? 2 variables, X and Y. How many terms 4 terms. Okay, 4 terms. Why? 1, 2, 3, 4 terms. See, there are 3 separators. 1, 2, 3 separators. That means 4 terms. There are 3 separators, no? So 4 terms. If there's 1 separator, 2 terms. Like see here, AB plus CD. How many separator? Only 1 separator. 2 terms are there. So 3 separators, 4 terms. You can count 1, 2, 3, 4 terms. Now, if you have to write out the terms of this algebraic expression, that's of 8th standard. But if you have to write out the terms, okay, what are the terms of the algebraic expression? So the first term is 8 by x squared. You must write the term along with the sign. you must mention the term along with its sign. The sign for the term is before the term, not after it. Okay, so 8 by x squared is the first term, plus 11x, or simply 11x is the second term, minus, look at the board, minus 6x cubed y square. Minus 6x cubed y square is the third term, and plus, or you don't have to, it's okay if you don't mention the plus sign. 3 by 10xy is the fourth term, correct? So you can see that the first example is an algebraic expression of 4 terms in 2 variables x and y. Is that explanation correct? Is an algebraic expression. The first one is an algebraic expression of 4 terms in 2 variables x and y, right? The second one, how many terms? 1, 2, 3 terms. How many variables? X, y, z. Don't see the powers. Don't say x to the power 4 is one variable, x to the power 3 is a different variable. No, no, no. Don't consider the powers. Just see the letter there. X, y, z. Ignore the powers. X cube, x square, x. Variable is x, that's all. Variable is x. Okay. So in the second example, there are 3 variables, x, y, and z. And the number of terms, 3. 3 terms. So the second one is an algebraic expression of 3 terms in 3 variables, x, y, and z. Right? Now let's understand what is meant by a polynomial. See, a polynomial is an algebraic expression. A polynomial is an algebraic expression. Then what is the difference? If a polynomial is an algebraic expression, then what is the difference between an algebraic expression and a polynomial? That's what we are made to understand till standard 8. It's not so. So what we may have understood in grade 8 is that if an expression has many terms, it's a polynomial. Is 1. No, see, you've learned a few things, so you're just trying to put them together. It's not that also. We'll see, all of us will get the right one, okay? Because nobody should get confused. I won't say you're wrong. You are giving me the definitions or the explanation for some other terms. You're right, but that's not what a polynomial is, all right? Okay. Right? Yeah, the teacher has been very positive. She's not supposed to say, no, you're wrong. What, you don't know. If I use that language. Yeah. So, where did I stop? Yeah, polynomial. So what is the difference between an algebraic expression and a polynomial? Now, if you have to call an algebraic expression a polynomial, you will have to consider, or you'll have to look at the powers of the variables involved. The algebraic expression will have one variable or more than one variable. See, you should internalize what I'm saying, not just listen to the sound which is coming out from my vocal cords. Understand what the sound means. Yeah. An algebraic expression may have one variable or more than one variable. Now, to decide or comment if that algebraic expression is a polynomial, you have to check the powers of the variable or the variables involved. If there's one variable, check the power. More than one variable, check the power. So check the powers of the variable or variables involved. Okay, in every term. The algebraic expression may have one term, two terms, three terms, many terms. So if the term has in the algebraic expression, if the algebraic expression, if the term has, okay, so in the algebraic expression, if a term has a variable, look at the power of the variable. And the power of the variable or the variables involved should be non-negative. Non-negative meaning it should not be negative. That's all. What is non-negative? It should not be negative. So non-negative means it should not be negative. That means it can be 0 or positive. Non-negative means it should not be negative. So it can be anything other than that. So what are the things, what are the integers other than non-negative integers? Non-negative means it should not be negative. So it can be 0 or positive. See, -3, -2, -1, 0, 1, 2, 3, and so on, right? These are, yeah, whole numbers, very good. So these are negative, right? These are negative integers, right? It should not be negative. It should not be negative, meaning it should not be this part. So then it can be this or this. So it can be 0 or positive. Non-negative means it should not be negative. That means it can be 0 or positive. The power of the variable everywhere should be non-negative. So the power can be 0 or positive. If the power of the variable or variables everywhere is non-negative, then that algebraic expression is a polynomial. All right. So an algebraic expression, this is the definition. An algebraic expression in which the variables involved have non-negative integral powers. Integral meaning of integers. Okay, like floral means of flowers, right? When we say a floral design meaning a design made up of flowers. Similarly, integral meaning of integers. Integral meaning of integers, made up of integers. An algebraic expression in a polynomial is an algebraic expression. An algebraic expression in which the variables involved have non-negative integral powers is called a polynomial. A very simple definition of a polynomial. Okay, we have one more. We'll see that in the next class because it is important, but we'll just go ahead. Okay, I don't want to spend time on that. So this is the definition of a polynomial. Got that? The variables must have non-negative integer powers. Okay, so that means the power can be 0 or positive. So like Surya said, the power should be a whole number. In simple words, the power should be a whole number. The power can be 0, 1, 2, 3, 4, 5, 6, and so on. Right? So look at the, let's check this one first. Now we said this one is an algebraic expression, right? Now this one is not a polynomial. Why? Because this one is not a polynomial. See, this one is an example of an algebraic expression, but this is not a polynomial. We'll see why. Now look at the first term. This is the first term, right? 8 by x squared. 8 by x squared. So when the variable is in the denominator, you should take it up to the numerator. When the variable is in the denominator, take it up to the numerator. So 8 by x squared is nothing but 8x to the power -2. Yes or no? 8 by x squared is equal to, so when you take the term to the numerator, the power, the power will take the opposite sign. So +2 becomes -2. So 8 divided by x squared is equal to 8 into x to the power -2. Okay, yeah. Okay, this is nothing but 8 into 1 by x squared. 8 by x squared is nothing but 8 into 1 by x squared. And 1 by x square is nothing but 8. 1 by x square is nothing but x to the power minus 2. All right. So 8 by x square minus 2. There itself, it's not a polynomial, no? Because in the first term, in this algebraic expression, the first term is 8 by x square, which should be treated as 8x to the power minus 2. The variable in the denominator. If a constant is in the denominator, ignore it. We are concerned only about the variable, right? So the variable x is in the denominator. So you have to bring that to the numerator. If a constant is in the denominator, ignore it. We are not going to look at the constant. Okay, so x is a variable. So bring it to the numerator. So it is 8. Okay, so it is 8x to the power minus 2, right? So what's the power of the variable x there? Minus 2. It's negative. It should be non-negative. It's negative. That's it. There itself, it's not a polynomial. It's an algebraic expression. An algebraic expression has no much conditions. Some constants, variables, plus minus sign, algebraic expression. Variable can be the numerator, denominator, power can be negative, positive, fraction, decimal, anything is an algebraic expression. But a polynomial is sensitive. Okay, so understand? But in the second term, what's the power of x? 1. It's a whole number. In the third term, there are two variables, x and y. The power of x is 3, whole number. The power of y is 2, whole number. Fine. In the fourth term, we have two variables, x and y. The power of x is 1, whole number. The power of y is also 1, whole number. Fine. Everywhere it's fine. But in the first term, the power of x is minus 2, which is not fine. So the expression is not a polynomial. It's not a polynomial. Is that fine? Yeah. Let's see the second one. The second one is also an example of an algebraic expression. Let's see if it's a polynomial. All right. So this is the first term. This is the first term. It has two variables, x and y. The power of x is 4, whole number. The power of y is 7, whole number. Good. Second term. We have 1 by root 2. We are not looking at all that. 1 by root 2 is not relevant to our check here, right? We are not checking on that. We are checking on the powers of the variables in every term. So the second term has two variables, x and y. The power of x is 3, whole number. The power of y is 2, whole number. So good. Third term, 4 by 7, z. Z is the variable. 4 by 7 is a fraction. See, 4 by 7 is not a whole number, but that is not our concern. We are looking at the power of the variable, nothing else. So in the third term, 4 by 7z, the variable is z and the power of the variable, not the coefficient. What is 4 by 7 for z? It's a coefficient of z. What is the relation? 4 in the term 4 by 7z, what does 4 by 7 mean to z? 4 by 7 is the coefficient of z. But who is which is the power of z? 1 is the power of z. So we are not looking at the coefficient. We're looking at the power. Coefficient can be anything. The power should be a whole number. Z is the variable. The power of z is 1. It's a whole number. So in the second example, which has 3 terms, the variables involved, the variables involved in all these 3 terms have whole numbers as their powers. So the second algebraic expression is also a polynomial. Online children, any questions? Am I clear?
Yes, ma'am. No, ma'am.
Okay, what's your question?
No, ma'am, I have no doubts.
Oh, okay. All right. So the confusion can be polynomial means it should have many terms. No. Polynomial can have even one term. Polynomial is not an expression with many terms as a polynomial. It's not so. So what is a polynomial? An algebraic expression in which the variables involved have non-negative integral powers. This is the definition of a polynomial. A polynomial is not an algebraic expression with many terms as a polynomial. No, no, no. An algebraic expression in which the variables involved have whole numbers as their powers is a polynomial. Okay. So that's about a polynomial. That's what is in this slide. Okay. So this also you can help yourself. Let's go through the three examples. So the first one is not a polynomial because y squared when taken up to the numerator is y to the power -2. And the power of y is negative, meaning it's not a whole number. So the first one is an algebraic expression, but not a polynomial. The second one is an algebraic expression as well as a polynomial. The third one is an algebraic expression, but not a polynomial. So am I right or wrong there? Have I made a mistake there or is it right? Huh? 4? Where is 4 power -5? No, in 4/5, which is the variable? 4/5 is a constant. So does that term have a variable in it? No. Y to the power 3. Y is a variable, right? No, no. Correct. It's because of the first term. It's because of the first term. So square root of 3x to the power 5 is nothing but 3x to the power 5, the whole power 1/2. Okay, so this is the radical form. This is the exponential form. Tell you again. In the third example, the first term, root of 3x to the power 5. Okay, so this is the radical form. In the exponential form, it looks like this, which can be written as 3 to the power 1/2 into x to the power. You'll have to multiply the power to every term in the bracket, right? So 3 to the power 1/2, x to the power 5 into 1/2, which is 5/2, which is 5/2. Yes or no? The power 1/2 is applicable to 3 and x to the power 5 inside the bracket. The power 1/2 is applicable to 3 and x to the power 5, which are in the bracket. So it's 3 to the power 1/2 and multiply the powers 5 into 1/2, 5/2. So x is raised to the power 5/2. So what do you say about 5/2? Is it a whole number? No, it's not a whole number. It should be a whole number. No lenience there. It should be a whole number. It's not a whole number. 5/2 is not a whole number. So the expression in 3 is an algebraic expression, but not a polynomial. So the new students have missed the first chapter, number systems. Exponents is a part of the first chapter, number systems. So please watch the recordings. Yes, so I'm not able to. You have any questions? You can ask me. Do you understand that part? Root of 3x to the power 5. You have any questions there? the cube root of x to the power 4y. This is the radical form. In the exponential form, it will be x to the power 4y. The whole power, what? The whole power? No, the whole power? 1 by 3. 1 by 3. The whole power 1 by 3. If it's cube root, so square root means to the power 1 by 2. Cube root to the power 1 by 3. Fourth root to the power 1 by 4. In the radical form, if you have the square root symbol, then in the exponential form, you should raise the base to the power 1 by 2. In the radical form, if you have cube root symbol, then in the exponential form, you must raise the base to the power 1 by 3. In the radical form, if you have the symbol, fourth root symbol, then you must raise the base to the power 1 by 4 in the exponential form. So cube root of x to the power 4y is equal to, right? This is the base. This is the base, x to the power 4y. The whole power, there is a camera in the class. So parents have questions as to why the child is not following. Look at the camera, see if your child is looking at the board or so cube root converts to the power 1 by 3. All right. Yeah. Is that fine? So this will be x to the power 4 by 3. Y to the power 1 by 3. Because 4 into 1 by 3 is 4 by 3. All right. So what have we seen so far? Constants, variables, algebraic expressions, polynomials. Very good. Okay. All right. Now, when you classify polynomials, you can classify polynomials based on two categories, based on the degree and based on the number of terms. Polynomials can be like, okay, let's relate it to something else, like angles. Okay, so angles can be, say, okay, triangles. Triangles can be classified based on the lengths of their sides and also based on the measure of their angles. Triangles can be classified based on the lengths of their sides and the measure of their angles, right? So based on the sides, if none of the sides are equal, scalene. If two sides are equal, isosceles. If all the three sides are equal, equilateral. Based on angles, if all the angles are acute angle to triangle. If one angle is 90 degrees, right angle to triangle. And then if one angle is obtuse angle to triangle. Above 90 degrees is obtuse. Obtuse angle is an angle more than 90 degrees, but less than 180 degrees. Acute angle, an angle which measures less than 90 degrees is an acute angle. An angle which measures exactly 90 degrees is a right angle. An angle that measures more than 90 degrees, but less than 180 degrees is an obtuse angle. Less than 90 degrees, acute angle. Equal to 90 degrees, right angle. More than 90 degrees, but less than 180 degrees, obtuse angle. So you can classify triangles based on the measure of their angles, right? Acute angle to triangle, right angle to triangle, obtuse angle to triangle. If all the three angles are acute angle triangle. One angle is right angle triangle. One angle obtuse angle triangle. In the same way, you can classify polynomials based on the number of terms the polynomial has, and also based on the degree of the polynomial. So we'll understand what degree means. We'll first see based on the number of terms it has. So if a polynomial has only one term, it's called a monomial. We're trying to understand the classification of polynomials based on the number of terms. I normally send the pre-work. The pre-work for polynomials, the old students know, I normally share the pre-work. So all this, whatever, we've been discussing and what we'll be seeing through the class, all this would have been shared with you, but I'm just out of the event, back to my normal routine. So I did not have time to send it. I need to prepare and share it with you. Okay, by tomorrow, I'll try to do that by tomorrow evening. All of you following, right? Yeah.
Yes, ma'am.
Very nice. So we are classifying polynomials based on the number of terms. A polynomial with only one term, one non-zero term. You cannot write zero and say it's a monomial. A polynomial with one non-zero term is a monomial. A polynomial with two non-zero terms. You can't write 0 plus 0. Okay, a polynomial with two non-zero terms is called a binomial. A polynomial with three non-zero terms is called a trinomial. A polynomial with four non-zero terms is called a monomial, binomial, trinomial, quadrinomial. 1 minute. Relax. See, you need to, so now you need to unlearn the incorrect. No, what's your name? Rahul. Yes, Rahul. Kindly unlearn the incorrect definition you have of a polynomial and learn the correct one. So you still have that, an expression with many terms as a polynomial in your mind. So which is why you're not accepting what I'm saying. Polynomial, we just understood, right? An expression in which the powers of the variables involved have whole numbers as their powers or non-negative integral powers. You're right, yeah. Non-negative integral powers. Whole numbers as their powers. This is the definition of a polynomial. Excuse me. Yeah. So monomial is a polynomial with one non-zero term. A binomial is a polynomial with two non-zero terms. A trinomial is a polynomial, not an algebraic expression. Polynomial. A trinomial is a polynomial with, so if you have to call an expression a monomial, it should first be a polynomial. If you have to call an expression a monomial, it is not enough if it is an algebraic expression. It should be a polynomial. Only if it's a polynomial, you can call it a monomial. If it's, see, if I write 1 by x square, 1 by x square. 1 by x square is not a polynomial. So you can't call it a monomial. It's an algebraic expression with one term. 1 by x square is an algebraic expression. 1 by x square is not a polynomial because 1 by x square is nothing but x to the power minus 2. The power of x, the variable x, is negative. It's not a whole number. So 1 by x square is not a polynomial. It is an algebraic expression. It is an algebraic expression having one term. It's not a monomial because it's not a polynomial. Yeah? Got it? Okay, 1 by x squared is an algebraic expression. 1 by x squared is not a polynomial because 1 by x squared is equal to x to the power minus 2. The power of the variable x is negative. It's not a whole number. So it's not a polynomial. If it is not a polynomial, then how can you call it a monomial? Because a monomial is a polynomial having a non-zero term, having one non-zero term. Meaning having one non-zero term, meaning it should have one term and that one term should not be zero. That's the meaning. A monomial is a polynomial with one term. But if you write 0 and say, yeah, take this example, it's a monomial. I've written only one term. No, you can't write 0 and say it's a monomial. Then you will write 0 plus 0 and say it's a binomial. Then you'll write 0 plus 0 plus 0 and say it's take this is a trinomial. No. Okay. So a polynomial with one non-zero term is a monomial. A polynomial with two non-zero terms is a binomial. A polynomial with three non-zero terms is a trinomial. That's enough. A polynomial with four non-zero terms is a quadrinomial. Quadrinomial. So monomial, binomial, trinomial, quadrinomial are the different types of polynomials based on the number of terms. Based on the number of terms. One term, two terms, three terms, four terms. Based on the number of terms. Okay. So quintic, we have quintic polynomial. We have, after that, we have special names. We don't have for everything, but for few we have. That's what. There's no, so that is a polynomial with 6 terms. That's all. No specific name. Or see, new things keep coming up, no? So maybe they've given a new name. You can just check that. Yeah. But we don't have for everything. For every other polynomial, we don't have special names. So after that, probably we have for 10, some 50, 100. Randomly we have. This is enough for you. Got it? Now we have two more polynomials called constant polynomial and zero polynomial. After monomial, binomial, trinomial, quadrinomial, one term, two, three, four terms, we have two more, zero polynomial and constant polynomial. Zero polynomial is, zero is called the zero polynomial. Zero is called the zero polynomial. That's all. So you can't say, give examples of zero polynomials. Zero, this number zero is called the zero polynomial. All right, that's all. Then what about constant polynomial? Every non-zero real number is a constant polynomial. See, we have, so you know the collection of real numbers, all rational numbers and irrational numbers put together. Rahul, are you focusing? You're listening to me? Okay. Then you have to look at the board or look at me. Looking at me. All right, so is it telling? Yeah, constant polynomial. Yes. So zero polynomial. Zero is called the zero polynomial. Zero is called the zero polynomial. Finished. Constant polynomial. So we know the collection of real numbers, right? Rational numbers and irrational numbers put together form real numbers. You can come here. Okay, leave your bag and all the thing. You just come here and sit. Okay. So the collection of all rational and irrational numbers form the collection of real numbers. From real numbers, take away zero. The rest of the collection are constant polynomials. From the collection of real numbers, take away the number zero because that number zero is a zero polynomial. Okay. Can you get the collection of real numbers in your mind, rationals and irrationals together? Okay. So now there is zero, right? Take away zero from there because what is zero? Zero is a zero polynomial. Zero is the zero polynomial. So take the rest away. The rest of the numbers are constant polynomials because they're all numbers. So they have a fixed numerical value. They're all numbers. So they have a fixed numerical value. So the rest of the collection are called constant polynomials. Every constant is a constant polynomial. 5 is a constant polynomial. Root 2 is a constant polynomial. A constant polynomial can be rational or irrational. See, other than zero, every rational and irrational number is a constant polynomial. Other than zero, every rational number and irrational number is called a constant polynomial. Why not zero? Because zero has a special name. It's the zero polynomial. That's all. No. It's a zero polynomial. The definition itself is a constant polynomial is the collection of all non-zero real numbers. Non-zero real numbers. They are all included, no, in the collection of real numbers. Integers are included in the collection of real numbers. An integer is a rational number, right? It's included there. All right. So that's about zero polynomial and constant polynomial. Now, understanding polynomials based on the degree. Okay, so for that, we need to understand what degree of a polynomial is. Okay. When the polynomial has only one variable, the highest power of the variable involved is called the degree of the polynomial. Let me give you some examples. Now consider the polynomial 5x to the power 5 minus 7x to the power 10. All right. Now this example which you see 5x to the power 5 minus 7x to the power 10 is an algebraic expression and is also a polynomial because the variable x in both the terms has whole number as its power. Correct? In the first term, the power of x is 5, whole number. In the second term, the power of x is 10, whole number. So this algebraic expression is a polynomial. Now we are trying to understand the degree of a polynomial. All right. Now look at this term, the first term. What's the power of the variable? 5. The second term, what's the power of the variable x? 10. Which one is greater in value? 10. So this one is a polynomial of degree 10. That's all. So this one is a polynomial of degree 10. Don't look at the coefficient. You must see the power, not the coefficient. One more example. Now 3y to the power 6 minus 4 by 7 y to the power 8 plus 100. Okay, this is one expression. This is one expression. So how many terms? 3 terms. 3 terms. How many terms? 3 terms. Okay, 3 terms. Correct. Now in the first term, what's the variable? Y. What's the power of y? 6. Note that. Note that. In the second term, what's the variable? Y. Y again. Y is the variable. What's the power of y? 8. Note that. In the third term, do you see any variable there? No. Ignore it. If there's no variable, ignore it. Okay. Now, between 6 and 8, which is greater? 8. 8. 8. So the degree of this polynomial, is 8. Now see the definition. When the polynomial explanation, not definition, explanation. When the polynomial has only one variable. Yeah, in this example here, the polynomial has only one variable y. In this example, which we have taken here, this one, the polynomial has only one variable y, right? Yeah. So when the polynomial has only one variable, the highest power of the variable involved is called the degree of the polynomial. Clear? Okay. Now let's see these examples. Now 4x minus 1 is a polynomial. Now in the first term, you see the variable x. This is the first term. The variable is x. Its power is 1. In the second term, you don't see any variable there. I have something to say. Actually, you can fix a variable. So like 1 means 1 x to the power 0. 1 means 1 x to the power 0. X to the power 0 because anything to the power 0 is 1. So there's x to the power 0. So still the power is 0. And the number bigger between 1 and 0 is 1. Yeah. But you can just leave it. I'm just telling you that 1 can also be looked at as 1 x to the power 0. Okay. So again, coming back to this. The first term, the variable is x, its power is 1. In the second term, we don't see any variable, so leave it. So the highest power, there's only one power, 1. So the highest power is 1. So if the highest power is 1, then the polynomial is called a linear polynomial. Okay, so that's the degree. Why is that the degree? Because that's the highest power. What's the highest power? 1. So what's the degree? 1. If the degree is 1, then the polynomial is called a linear polynomial. Next one. In this example, first term, variable is y, power is 1. Second term, variable is y, power is 2. In the third term, no y, so leave it. Now between 1 and 2, which is big? 2. 2. So the degree is 2. The bigger of the two numbers is the degree. So 2 is greater than 1. So 2 is the degree. If the degree is 2, then the polynomial is called a quadratic polynomial. How do you find the degree? The greatest of the powers involved, right? So you have power 1 here in the first term, power 2 here in the second term. And 2 is the greatest power. So that means the degree is 2. So it's a quadratic polynomial. If the degree of the polynomial is 2, it's called a quadratic polynomial. And in this example, z to the power 3 is a polynomial. See, there's only one term. It's a polynomial. Why is it a polynomial? Because the power of z is a whole number. The power of z is a whole number. So it's a polynomial. Z is the variable. And the power of z is 3, which is the whole number. So it's a polynomial. And there's only one term. The power is 3. So the highest power is 3. And if the highest power is 3, the degree is 3. And if the degree is 3, the polynomial is called a cubic polynomial. Highest power is the degree. And with the degree, you can give the name for the polynomial. If the highest power is 1, then the degree is 1. If the highest power is 2, degree is 2. If the highest power is 3, the degree is 3. If the highest power is 4, degree is 4. If the degree is 1, it's called a linear polynomial. If the degree is 2, quadratic. If the degree is 3, cubic. If the degree is 4, biquadratic. So how do you find the degree? Using the powers. The greatest of the powers will be the degree. Is that fine? So in the last one, here the power of the variable p is 2. The power of the variable p is 1. The power of the variable p is 4. 2, 1, 4. 4 is the greatest number. So the degree is 4. And if the degree is 4, it's called a biquadratic polynomial. All right? Yeah. Hmm. You're saying you want to give a different name for that, is it? Instead of biquadratic, you want to call it something else. Correct. Quadrilateral means 4. Huh. See, quadratic means 2. Bi means into 2. So 4. See, like when we say bi-monthly meaning every 2 months. Bi-monthly meaning every 2 months. So here, how do you understand the term bi-quadratic? Quadratic means 2. Bi-quadratic means 2 into 2, 4. So bi-quadratic. Yes. Yeah, that's the next one. That's on the next slide. So far, we've understood how to find the degree of a polynomial where the polynomial involves only one variable x or y or z or any letter. That's why you see the heading here, degree of a polynomial in one variable. If the polynomial has only one variable, how to find the degree is what we've understood in this slide. See the next one. Degree of a polynomial in more than one variable. Okay, so look at the examples. Look at this one. We'll understand this later. Okay, look at this example. This one is a polynomial. This one is a polynomial. How many terms? 1, 2, 3, 4 terms. Okay, 4 terms. Take the first term. There are two variables, x and y. There are two variables. Now what to do? Find the sum of the powers. Because for every term, you should write only one number. For every term, you should write only one number. You can't write 2, 3, 4 numbers for one term. So now when you look at the first term, there are two variables, x and y. The power of x is 4. The power of y is 7. What is 4 plus 7? 11. Write that. Was this your question? Okay. Look at the second term. How many variables? Only one variable. What is it? Y. What's the power? 14. Write it. Third term. How many variables? 2. What are they? Y and Z. What's the power of Y? 1. What's the power of Z? 2. What is 1 plus 2? 3. So write 3 for the third term. Fourth term. Only one variable and its power 9. Write that. Now, which is the greatest of these four numbers? 14. So the degree of this polynomial is 14. The highest power, the greatest of these four numbers is 14. So the degree of the polynomial is 14. All right. See the next one. First term, two variables x and y. Power 2, power 3. So 2 plus 3, 5. Power x, power y. 1 plus 2, 3. X means x to the power 1. So 1 plus 2, 3. Here in 7, no variable. Leave it. Here, one variable, x, 4. Now 5, 3, 4. 5. Degree 5. That's it. So we have understood how to classify polynomials based on the degree and based on the number of terms. 1 term monomial, 2 terms binomial, 3 terms trinomial, 4 terms quadrinomial. And then we also saw two additional terms, zero polynomial and constant polynomial. Zero is called the zero polynomial. All other non-zero real numbers are called constant polynomials. From the collection of real numbers, take away 0 because that name. From the collection of real numbers, take away 0. The rest of the real numbers are constant polynomials. 0 is called the zero polynomial. All right. Then classifying polynomials based on degree. If the highest power is 1, linear polynomial. Highest power. Okay, if the highest power is 1, then the degree is 1. And if the degree is 1, it's called a linear polynomial. If the highest power is 2, the degree is 2. If the degree is 2, it's a quadratic polynomial. If the highest power is 3, the degree is 3. And if the degree is 3, it's a cubic polynomial. If the highest power is 4, the degree is 4. And if the degree is 4, it's called a biquadratic polynomial. Highest power is the degree. And from the degree, you can give the name of the polynomial. All right. Online children? Any questions?
No questions, ma'am.
No, ma'am.
Okay. Okay. Next, we're going to understand the number of zeros a polynomial has. The number of zeros. There's a different thing. The number of zeros a polynomial has. Okay. Now let's just take a linear polynomial, a very simple one, say 4z minus 20. Now this one is a linear polynomial. Okay, it's a polynomial. It's linear because 4z, z is the variable, its power is 1. So the degree is 1. So it's a linear polynomial. Now you equate it to 0 and solve it. Equate it to 0 and solve it. So 4z is equal to 20, z is equal to 5. Now phi is called the solution of this linear equation. 5 is the solution. 5 is a solution of the linear equation. Linear equation 4z minus 20 is equal to 0. Now the same number 5 is called, 5 is the 0 of the linear polynomial. Linear polynomial 4z minus 20. See, so that same number, that answer you got 5, no? When you say linear polynomial, you must say 0. Linear equation, we say solution. That's all. See here. Here I've used the term linear equation. So I have written 4z minus 20 is equal to 0. Equation, no? So 4z minus 20 is equal to 0. Here I've called it linear polynomial. Linear polynomial, see what I've written here, 4z minus 20. Equal to 0 is not there. The linear polynomial, right? Only equation will have the equal to sign. So 4z minus 20. Now this number 5, when you say linear, for the linear polynomial, 4z minus 20, 5 is called the 0. For the linear equation 4z minus 20 is equal to 0, 5 is called the solution. It's also called the root. One more term is there. It's also called the root. Root and solution, these two terms are used for equation. 0 is used for polynomial. That's all. And how do you find the 0 or the root? By solving the polynomial, by equating the polynomial to 0. If you have to find the 0, you should equate the polynomial to 0. See, we have this polynomial 4z minus 20, right? You want to solve it. Then you should equate it to 0. When you solve, you get z is equal to 5. Now, this 5 is called the solution or root of the linear equation 4z minus 20 is equal to 0. The same number 5 is called the 0 of the linear polynomial 4z minus 20. Expression, correct. All right. Okay. So this is what is about the 0. Now, how do we understand this better? 4z minus 20 is equal to 0. Now we just understood that 5 is the root or 5 is the solution of this equation. It means what? Okay. When you take the LHS, 4z minus 20, and in place of z, when you use 5, what do you get? 0. What's the RHS? 0. So LHS is equal to RHS. So 5 is the only value that can satisfy this equation. 5 is the only value that can satisfy this equation. that can make the LHS and the RHS of the equation equal. You give some other value for Z. Give a different value for Z. 4Z minus 20. Say 3. Suppose we take 3. So this is the equation. We'll use the left-hand side first. 4Z minus 20. We'll take Z as 3. Okay, so 4 into 3. 4 into 3 minus 20. 12 minus 20 minus 8. So the value of the left-hand side is minus 8. But what's the value on the right-hand side? 0. Is the left-hand side equal to the right-hand side? No. But it's an equation, no? It's the given thing is an equation, but it's not equal. What is an equation? Both the sides are equal. The left-hand side and right-hand side, they're equal. That's why it's called an equation. But they're not equal. That's because 3 is not a solution of this equation. Why the left-hand side is not equal to the right-hand side? Because we have taken 3 as a solution, which is not a solution. If 3 were a solution, then the value you get on the left-hand side will be the same as the value you have on the right-hand side. LHS will be equal to the RHS. And it will be equal only when Z is 5, not for any other value of Z. We understand that, right? In the equation 4Z minus 20 is equal to 0. When Z takes the value 5, the left-hand side will be equal to the right-hand side. For no other value of Z other than 5, the LHS will be equal to the RHS, which is why we say 5 is the only solution of this linear equation. That means a linear polynomial has only one zero. That means a linear polynomial has only one zero. Now we have solved, that's about the zero of a linear polynomial. So we understood that a linear polynomial has only one zero. See, I'll just work, I'll not talk. I'll just take another example of a linear polynomial. So just take a very simple one. So like say 3x, you can take anything, but we'll not spend time, with all that, with fractions and all that. So 3x, say minus 24 or plus 24 is equal. Okay. So somebody's talking, I'm getting distracted. 3x plus 24. This one is a linear polynomial. Now 3x plus 24 is equal to 0. Is a linear equation. Now let's solve this linear equation. 3x is equal to minus 24, x is equal to minus 8. Now minus 8 is the only root or the only solution of this linear equation. Or minus 8 is the only zero. 0 here does not mean the number 0. Okay, yeah, correct. So minus 8 is the only zero of this linear polynomial 3x plus 24. 0 is associated with polynomial, solution and root. These two terms are associated with equation. Okay, now x is minus 8. Now let's take the LHS. 3x plus 24. And in place of x, we'll use minus 8. So minus 24 plus 24 is 0. And what's the RHS? 0. So LHS is equal to RHS. All right. Now last year in class 8, yeah, you have solved quadratic polynomials by splitting the middle term. Yes, we have. X square minus 5x plus 6. How do you factorize this? Sum is minus 5. Product is 6. Minus 3 into minus 2. Correct. So the two numbers are minus 3 and minus 2. x square minus 5x plus 6 is a quadratic polynomial in one variable x. Because you can see the highest power is 2. So it's a quadratic polynomial. It's a polynomial. It's not an what you see there is not an equation because there is no equal to sign there. You don't see the equal to sign. It's a polynomial. And the highest power is 2. So it's a quadratic polynomial. And last year we have seen how to, find the factors of this quadratic polynomial by splitting the middle term. So x square minus 3x minus 2x plus 6, right? Then x is common, x minus 3, minus 2 common, x minus 3, x minus 3 into x minus 2. Not able to recall? This is how we factorize. See, last year we've studied algebraic expressions and identities and also factorization. In class 8, we had this chapter factorization. So in that chapter factorization, we have learned how to factorize expressions. See, last year we did not look at this as quadratic polynomial. We only looked at it as an expression. Factorize the following expression. Now, since we know this term quadratic polynomial, we are giving a specific name. That's a general term. Expression is a general term. In the zoo, you have many animals. Animals, general term. You look at the giraffe and say this is a giraffe, so specific. So now you're giving a specific term. X square minus, it's called x square minus 5x plus 6 is an expression. It's a quadratic polynomial in one variable x. Okay, so last year we have learned how to factorize this expression by splitting the middle term. These are the two factors, x minus 3 and x minus 2 are the two factors. Now, to find the zeros, we understood that we'll have to equate it to 0. To find the zeros, you'll have to equate it to 0, equate it to 0, equate it to 0. Now, when the product is 0, one of them have to be 0. If I say 5 into dash is 0, I think it is 0 here. If the product is 0, then one of the, see, 0 into 0 is 0, then meaning doesn't make sense. There is something, but the product is 0. So that means the other thing is 0. There is something like this, but when this is multiplied with something, the product is 0. That's because this one is 0. So here, when you equate, now here this product is 0. You can say x minus 3 into x minus 2. This product is 0. That means either x minus 3 is 0 or x minus 2 is 0. So x minus 3 is equal to 0 means x is equal to 3 on transposing, or x is equal to 2. So 3 and 2 are the two roots or the two solutions of the quadratic equation. 2 and 3 are the zeros of the quadratic polynomial. So you see that a quadratic polynomial has two zeros. So like this, we are not going to solve the rest of it. We are not going to solve a cubic polynomial by quadratic, and I'm not going to show you that they have 3 and 4 zeros. So this is so you should get the idea using, these two examples. That is, we've solved a linear equation, and here we have solved a quadratic equation. When we solved a linear equation, we found the solution. We got only one value, right? When you solve a linear equation, you got only one value for x or the variable. And that one value is the 0 of the linear polynomial. Now here, quadratic polynomial, to find the two values, you will have to equate it to 0 and work. So on doing so, you get x3. Yeah, so you when you work this, you get x3 or x2. So 2 and 3 are the solutions or roots of the quadratic equation, also called the zeros of the quadratic polynomial. Roots, solutions are associated with equation. Zeros, polynomial. Same number or numbers. All right? Okay. Now let's see this. Now see this. A linear polynomial means the degree is 1. It'll have only 1 0. We worked and we just checked that. Quadratic polynomial means the degree is 2. And it'll have a maximum of 2 zeros. It cannot have more than 2. It cannot have more than 2. It can have a maximum of 2 zeros. Okay, I cleared the screen. Sorry, I should have told you this. 1 minute. So for x square minus 5x plus 6 is equal to 0, they got x is equal to 2 or x is equal to 3, right? Now take the LHS. Take the LHS. X square minus 5x plus 6 is the LHS. Now take x as 2. So 2 square minus 5 into 2 plus 6. 4 minus 10 plus 6. 4 minus 10 is minus 6 plus 6, 0. RHS, 0. LHS is equal to RHS. So 2 satisfies the equation. Now let's take 3. LHS, x square minus 5x plus 6. Take x as 3. 3 square minus 5 into 3 plus 6. 9 minus 15 plus 6. 9 minus 15 is minus 6 plus 6, 0. RHS, 0. So 2 and 3 will be the only two values that can satisfy this quadratic equation. You take any, okay, I'll just show you for one. We'll just take some of the value. Okay, we'll just take, say, minus 1. Okay, LHS, x square minus 5x plus 6. Let's take minus 1. Take anything, I'm just taking minus 1. Minus 1 the whole square, minus 5 into minus 1 plus 6. So 1 plus 5 plus 6, 6 plus 6, 12. But RHS is 0. So LHS is not equal to the RHS. For no other values other than 2 and 3, the equation will be satisfied. For this equation, x squared plus 5x plus 6 is equal to 0. Only the numbers 2 and 3 will satisfy the equation, will make the LHS equal to the RHS. For no other value of x will this equation be satisfied. So 2 and 3 are the only two zeros of the quadratic polynomial x square minus 5x plus 6. Cubic polynomial means the degree is 3. Number of zeros, 3. Biquadratic polynomial, degree is 4. Number of zeros, 4. Constant polynomial. These are the different polynomials we understood, right? Linear, quadratic, cubic, and biquadratic. So linear is degree 1, quadratic is degree 2, cubic is degree 3, biquadratic is degree 4. If the degree is 1, the number of zeros is also 1. Degree is 2, number of zeros 2. Degree 3, number of zeros 3. Degree 4, number of zeros 4. Can have a maximum. Maximum number of zeros 2. Maximum number of zeros 3. Maximum number of zeros 4. Constant polynomial. Constant polynomial. So what's a constant polynomial? So you'll have to listen to these two carefully. Okay. So what is a constant polynomial? What we understood is we'll have to consider the collection of real numbers. Constant polynomial. Consider the collection of real numbers. And from that collection, take away 0. The rest of them. The rest of the rational and irrational numbers. are constant polynomials. So that includes, other than 0, meaning positive numbers, negative numbers, fractions, decimals, like square root of 2 by 3, irrational numbers, everything. Any number you can write other than 0 are constant polynomials. And what is the 0 polynomial? 0 is the 0 polynomial. So that we know. Now we're trying to understand the degree. We are trying to understand the degree of a constant polynomial, the degree of a 0 polynomial, the number of zeros of a constant polynomial, the number of zeros of a 0 polynomial. Right? Listen carefully. Now let's see constant polynomial. Okay. Constant polynomial. Or let me say -3. It's a constant polynomial. Now for degree, there should be variable, no? Variable power, highest power degree. Variable power, highest power degree. There is no variable only. So you use a variable x. But if I write if I write -3 as -3x, they are different. -3 is not the same as -3x, right? So I'll put 0 here. Now it's 0. Because what is x to the power 0? 1. And what is 1 into -3? -3. Why are we introducing the variable? Because we want to identify the degree of this polynomial. To identify the degree, there should be a variable, because with the help of its power, we can identify its degree. I'll give another example. So say like -7 by 4. There is no variable. So write y. But if you simply write y, it's not the same. So say y to the power 0. So what is y to the power 0? 1. And what is 1 into -7 by 4? -7 by 4. So -7 by 4 is the same as -7 by 4 y to the power 0. Use any variable. A, B, C, D, any variable you can use. All right. Are you reading a storybook, Netra? Okay. Now, what's the variable? Y. What's the power of y? 0. What's the highest power? 0. So the degree is 0. So the degree of a constant polynomial is 0. No doubts. 1 minute. Okay, constant polynomial. Say 100. Okay, we are understanding what? Degree. For degree, you need variable. So let me write the variable. So 100. So let's write 100 as 100 c to the power 0. Because c to the power 0 is 1 and 1 into 100 is 100. All right. So 100 is the same as 100 c to the power 0. Now the variable is c. What's the power? 0. What's the highest power? 0. So the highest power is the degree, right? So what's the degree? 0. So the degree of a constant polynomial is 0. The degree of a constant polynomial is 0. Can you see here? Degree of a constant polynomial is 0. Contains one constant term, which is any non-zero real value. Which is any non-zero real value. All right. Now we'll understand this one. We'll understand this one. Degree of a 0 polynomial. Contains only one term, namely 0. Ready? Ready? Now 0. 0. Now we're trying to understand the degree of 0. There's no variable. So we're going to write 0 as 0x to the power 0. But you can also write it as 0. See, 0 can be written in different ways. 0 is 0 x to the power 0. 0 is also 0 y to the power 100. 0 is also 0 some b to the power minus 55. Because ultimately 0 into anything is 0 only, right? 0 into anything is 0. 0 into anything is 0. So 0 can be written in umpty number of ways. You can write it in write anything with 0, the value is going to be 0 only. 0 into anything. 0 into ABCD is 0. Okay, so you can write 0 in many ways. 0 can be written as 0 x to the power 5. 0 can be written as 0 y to the power minus 72. 0 can be written as 0 z to the power 20. I'll not use a negative power here because we're talking about polynomials. So here, what's the power here? 5. Then what's the highest power? 5. So what's the degree of 0 there? 5. Okay. What's the power here? 72. What's the highest power? 72. Then what's the degree? 72. What's the power? 20. Highest power? 20. Then degree? 20. What for one number we are giving different degrees? Degree has to be one answer. Degree of 0 has to be one answer. But we can give different answers, right? So we say the degree of 0 is not defined. Not defined meaning it's not one answer. It's not one answer. In that case, we say it is not defined. It's not defined meaning there is no one answer to this question. So the degree of 0 is not defined because 0 can be written in different ways. 0 into 0 into any variable raised to any power. So you'll get different values. You'll get different degrees. So each one of you can say different degrees for 0, which is why we say the degree of 0 is not defined. The degree of 0 is not defined. The degree of a constant polynomial is 0. There's nothing to get confused. You just have to write it. With a calm mind, just write a constant polynomial, 100. Okay. We're going back to constant polynomial. Okay, constant polynomial 100. So 100, we write it as, you cannot write 100 as 100x square because 100 is different from 100x square. Okay, so you can write 100. You can write 100 as only 100. Any variable you write, but power should be 0 only. Okay, now y to the power 0 is 1. And 1 into 100 is 100. Okay. Or you can write 100 as 100, z to the power 0 only you can write. You can't write 1, 2, 3, 4 because that is not 100. So whatever variable you fix with 100, the power can be 0 only. Only then the value will be 100. So what's the degree of a constant polynomial? 0. Because the highest power, because the power is 0, the highest power is 0, so the degree is 0. So the degree, so you don't have to remember at all. Just take an example and write like this. This is the power, this is the highest power, so this is the degree, that's all. 10 seconds. But for 0, 0 can be written in many ways. 0, 0 x squared, 0, 0 x to the power 1000, 0 is 0, ABCD. Now, when it is ABCD, the power of A is 1, the power of B is 1, the power of C is 1, the power of D is 1. So add all the powers, 1 plus 1, 2, 3, 4. The power is 4. So the highest power is 4. So the degree is 4. Here the degree is 4, here the degree is 1000, here the degree is 2. So the degree of 0 is not defined because you have many answers. Okay. Now coming to the number of zeros. Number of zeros, okay, of a constant polynomial. Now, number of zeros meaning, what did we understand in these examples? If you use the solution in the equation, the left-hand side will be equal to the right-hand side. You work the polynomial, you work the equation, you get 1 or 2 values accordingly, and when you put it in the left-hand side, you get it's equal to 0, which is the right-hand side. Now, when you take a constant polynomial, 6 by 9, 6 by 7. Okay. Now we said 6 by 7 is what? 6 by 7 x to the power 0. Now for what value? See, the first thing is 6 by 7 is already constant. It's a constant, right? Now this one, will it be, how can it be 0 then? What do you mean by a 0? When you put the value in that polynomial or that equation, the equation is satisfied. The left hand side will be equal to the right hand side. Now 6 by 7 is a constant. Now its value cannot be 0, right? Because it's a constant. Now for no value of x, will 6 by 7 become 0? For no value of x, can 6 by 7, because it's a constant. A constant means what? It assumes a fixed value. You cannot change its value. A constant assumes a fixed value. So 6 by 7 is 6 by 7. Now for no value of x, now supposing x is 3. What is 3 to the power 0? 1. And what is 1 into 6 by 7? 6 by 7 only you will get. For no value of x, can this one become 0? 6 by 7 can be written as 6 by 7 x to the power 0 for no value of x, because whatever value you give for x, that to the power 0 is 1, and into 6 by 7 is 6 by 7 itself. You cannot get 0. You cannot get 0. So a constant polynomial has no zeros. A constant polynomial has no zeros, because whatever value you give for x, to the power 0 is 1, and 1 into 6 by 7 is 6 by 7 itself. You will get the same constant. You cannot get 0. For no value of x can you get 0. Whatever value you give for x, that to the power 0 is 1, and 1 into 6 by 7 will give you the constant polynomial itself. So for no value of this variable, can this one become 0? So a constant polynomial, because it's a fixed value, has no zeros. A constant polynomial has no zeros. The degree of a constant polynomial is 0. The degree of a constant polynomial is 0. But a constant polynomial has no zeros. The degree of a constant polynomial is 0. But a constant polynomial has no zeros. There is no value of x which can make this one 0. Because whatever be the value of x, to the power 0 is 1, and 1 into 6 by 7 is 6 by 7 itself. For no value of x, this can be 0. So a constant polynomial has no zeros. Now for 0, we said 0 can be written in many ways. It can be written in many ways. So we understood that 0 has no degree, because there is no one answer for this. So the degree of 0 is not defined. The degree of 0 is not defined. Now give some value for x, say -1. Okay, -1 squared. -1 squared is 1. And 1 into 0 is 0. Give any value for x, say some 5. 5 to the power 33, some big value. Into 0, 0. Whatever value you give for x, the end result is 0. So every real number is a 0 of the 0 polynomial. Because you can take any value for x. Whatever value you fix for x. So say x is here, say x is 10. 10 to the power 33, something. Into 0, 0. So whatever value you fix for x, any real value, that into, so that real value to the power 33 into 0 will be 0 itself. So every real number is a 0 of the 0 polynomial. Every real number is a 0 of the 0 polynomial. Let's just see these two things quickly again. Just give you a break for a minute. We'll just see 0 polynomial and constant polynomial again. That is with respect to their degree and the number of zeros. Okay. Yeah. Okay. So minus 11 by 17 is a constant polynomial, which can be written as okay. So the degree, the power is 0, the highest power is 0, so the degree is 0. So the degree of a constant polynomial is 0. Now, how many zeros does it have? How many zeros does a constant polynomial have? Whatever value you give for y, whatever value you give, that to the power 0 is 1. And 1 into minus 7 by 17 is minus 11 by 17. You cannot get 0. You must get 0. If it is a 0, you must get 0 as the answer. That's what we got everywhere, no? When we put the value in the left hand side, didn't we get the answer as 0, which was in the right hand side? When we solved the linear equation and quadratic equation, so the quadratic equation, we got two values, right? 2 and 3. So on the left hand side, when we took x as 2, x as 3, what answer did you get? 0, which is the right hand side, right? You must get 0 here. So some value for y to the power 0 is 1. And 1 into minus 11 by 17 is minus 11 by 17. You're not getting 0. When can you get 0? You'll never get 0 because y to the power 0 is always 1. Whatever be the value for y to the power 0 is going to be 1 only always. That's fixed. So you're not bothered about the value of y. Whatever value I'm going to say, you're going to, that to the power 0 is 1. And 1 into minus 7 by 17 is minus 7 by 17. So there is no value of y which can make the value of this expression 0. So a constant polynomial has no zeros. It's easy to remember because a constant polynomial means fixed value. Then how can that become 0? It already has this fixed value minus 7 by 17. So then how will it become 0? So a constant polynomial has no zeros. But what's the degree of a constant polynomial? Degree is 0. Degree is 0, but it has no zeros. Then coming to 0, which is the 0 polynomial, the degree is not defined because 0 can be written in many ways. 0 can be written like this. 0 can be written like whatever. Everything is 0, right? If you write 0 as 0ab to the power 23, it's 0. 0 into that is 0 only. So when you present 0 in different ways, you'll get different powers, so different degrees, which means 0 has, you cannot give one answer for that. So the degree of 0 is not defined. And how many zeros does the 0 polynomial have? Every real number is a 0 of the 0 polynomial. Why? Now, because if you give any value for a, to the power 200, some big, huge value, into 0, 0. Are you getting 0? Yeah, then it is a 0. Then that value is a 0. That value you gave for a is a 0. Give any value for a. So you have so many values for a. And that value of a to the power 200. Say you calculated using a scientific calculator, you calculated into 0, 0. So that means whatever be the value for a to the power 200 into 0 is 0 only, right? So zero, the polynomial, this polynomial, the zero polynomial has many zeros, or every real number is a zero of this zero polynomial. Any real number you can take for a to the power 200 into 0 is 0. So every real number is a zero of the zero polynomial. So that's what is in this table. We see it again. Linear polynomial, degree 1. You're going to take up a test now. Okay. Linear polynomial, degree 1, number of zeros 1. Quadratic polynomial, degree 2, number of zeros 2. Cubic polynomial, degree 3, number of zeros 3. Biquadratic polynomial, degree 4, number of zeros 4. Constant polynomial, degree 0. Number of zeros, no zeros. Because it is a constant, it's a fixed value that cannot become 0. So it has no zeros. Zero polynomial, degree is not defined. Number of zeros, every real number is a zero of the zero polynomial. So this table is important. This is homework. I'll share it with you later. Which of the following expressions are polynomials is homework. I'll share this with you later. Yeah. Write 3 binomials of degree 100. You must give 3 examples of binomials of degree 100. Yeah, tell me. You can just try in your book and read it out for me. You can use one variable or more than one variable. You can use one variable or more than one variable also. That condition I have not given here, so you can use one or more than one variable. Just do it. No, do it behind. Don't do it in the first page, do it behind here. Yeah. Online children, use the emoji, raise your hand. Very good. Harsha, Shriya, and Lakshana, thank you. Very good. Yes. I'll be happy if any of you online can answer this. Yeah. Yes. Read one from your book. 4x to the power 100 plus 6. Yeah. So it is a binomial because 2 terms. And the degree is 100. Yeah, because the highest power of x is 100. So he's right. 4x to the power 100 plus 6. It's a binomial. Check both the conditions. Is it a binomial? Yes. There are 2 terms. So it's a binomial. And is a degree 100? Yes, because here there is no variable. In this term, the variable is x and the power is 100. So the degree is 100. Good. Anyone else? Yes. Plus y. Okay. So what? This is a binomial. This is a binomial. There are 2 variables, x and y. In the first term, the variable is x and the power is 100. In the second term, the variable is y and the power is 1. The greatest power is 100. So the degree is 100. Correct. But this is an example of a binomial of degree 100 with two terms, x and y. That's fine. Use more than one variable and give me examples. Yeah. 2 y to the power 50 plus oh, interesting example. Very good. Okay. So how many terms? 1, 2. There's only one separator. 2 terms. So it's a binomial. So one part of it is correct. It's a binomial. Now the second part is a degree 100. So in the first term, there are two variables, y and z. And their powers are 50 and 50 respectively. So you should add the powers, 50 plus 50, 100. So the highest power is 100. So the degree is 100. She's right. Correct? So this is a binomial. So there are three things here. This is an example of a binomial in two variables of degree 100. It's a binomial. There are two variables, y and z, and the degree is 100. Your teacher says in only one variable, then you cannot give this example. Then you will say, we discussed like this in the class, but my teacher did not give me marks. That's because if the question says one variable, you should use only one variable. And then the example will be like this, x to the power 100 minus 7. For two terms, binomial, and degree is 100. So be careful. See all the conditions before you write the example. Okay. Next one, monomial of degree 23. Sorry? Yeah, tell me. Loud. X power? எனக்கு தான் கேட்கலையா? Minus x power 23. Minus x to the power 23. Very good. Minus x to the power 23. Monomial of degree 23. This is a monomial. Only one term of degree 23. You can use more than one variable also. If that condition is not given, that you should use only one variable, you can use more than one variable. 16 power 23. Okay. Now this is discussion. Now is this example, does this example satisfy these conditions? Is a discussion. Plus 7 வந்தா அது binomial ஆயிடுமே. Hmm. 6 x to the power 20 and y cubed like this. Yes. Correct. This is correct. It's a monomial, and that means there's only one term, and in the term there are two variables x and y, power 20 and 3. So 20 plus 3 is 23. So the degree is 23. Correct? Sure. Minus போட்டா binomial ஆயிடும். எதுவே போடக்கூடாது. செப்பரேட்டர் போட்டாலே ரெண்டு டேர்ம் ஆயிடும்ல. பிளஸ் மைனஸ் வரக்கூடாது மோனோமியலுக்கு. Monomial. Say without the sign. $20. Yeah. Ignore this. Tell me something else. 10 power வேண்டாம். 10 variable. Correct. Very good. So I have some examples here. Please have a look. Analyze the examples, then I'll tell you. And then we'll discuss. See, this chapter, in school, you will be seeing only in one variable x, y, or z. So don't think why she's saying. It's just to have a better idea. All right. So you can see binomial of degree 100. Easily you can write the example. Degree should be 100, no? So x to the power 100 plus 5. Finished. Yes or no? So I have given different examples like this using more than one variable just for better understanding. Yeah. Now look at the first example. X to the power 25 plus yz to the power 99. Is it a binomial? Yeah, it's a binomial. There are two terms. What's the power of x? 25. In the second term, there are two variables y and z. What's the power of y? 1. What's the power of z? 99. What's 1 plus 99? 100. So in the second term, what's the power? 100. 25, 100. Which is bigger? 100. So the degree is 100. So x to the power, you don't see the number 100 there. But x to the power 25 plus yz to the power 99 is a binomial of degree 100. Because y is raised to the power 1 and z is raised to the power 99. 1 plus 99 is 100. So the second term has power 100. First term 25, greatest of the 200, so degree 100. Correct? Second one is easy, no? Y to the power 100. If so, your teacher says only one variable, you can write the second example. Y to the power 100 plus root 6. Plus can be anything, root 6, whatever. Any real number, but you should not write 0. You can't put plus 0. That does not make it two terms. Third example. Third example, we'll ignore the second part 7 by 8. We'll ignore that because degree 7 by 8 has nothing to do with the degree. So we'll see the first, it's a binomial. Now, z to the power 200, the radical square root will become into 1 by 2, correct? 2 and yeah. So what is z to the power 100? So this one, this is nothing but z to the power 200 into 1 by 2. 2 ones are 200 times. So there's nothing but z to the power 100. Z to the power 100. So that also is an example of a binomial of degree 100 and only one variable z. Only one variable z. So you MCQs, you might be given 4, options like these, and you have to select the right option which satisfies these conditions. Binomial of degree 100. So for that, understanding with examples like this becomes important. If you're asked to write an example, you will write a simple one. But if you're given 4 and asked to choose the one which satisfies the conditions given, you should have a better understanding. Because when something is already given and you have to interpret them, then you need a better understanding. Example, that's why we need to understand this. Okay? Is this one understood? Is this a binomial? Yeah. Is the power of z 100? Yes. The power of z is 100 because it is z to the power 200. Square root is into 1 by 2. So 2 ones are 200 times. So this one is nothing but z to the power 100. Okay. See these examples. The first one is The first one is a monomial of degree 23 in 4 variables A, B, C, D. See, take care of that. I told you in school, mostly it's only in one variable X, Y, or Z. Okay, so if you're asked to write a monomial of degree 23 in one variable, then you cannot write the first example. You can write the second or the third one, but not the first one, because that is in more than one variable. A இருக்கு, B இருக்கு, C இருக்கு, D இருக்கு. அதை எழுத முடியாது for an example in one variable. Second and third எழுதலாம். Okay, so is this right? Is it a monomial? It is a monomial. Because you don't see the plus minus separator, plus minus sign illa, appo adu monomial da. Okay, so A oda power 1, B oda power 1, C oda power 1. So 1 plus 1, 2, 2 plus 1, 3 plus 20, 23. The power is 23. Just because you see 20 here, the power is not 20. The power is what? The sum of the powers of the variables involved. Okay, so it's 23 here. Here it's easy, it's 23. And here it is. What is square root of, yeah, solve that. Solve this one and see, children. See the result and check if the result is a monomial of degree 23. Yeah. So how do we solve this? Square root of x to the power 47 is x to the power 47 into 1 by 2, correct? Divided by x to the power 1 by 2, correct? Now, it is x to the power 47 by 2 divided by x to the power 1 by 2, correct? Now, by the law of exponents, when bases are same and its division, we subtract the powers. So it will be x to the power 47 by 2 minus 1 by 2. So it is x to the power 47 minus 1 by 2. So it is x to the power 46 by 2, which is x to the power 23. We'll do it again together. See here. Square root of x to the power 47 by square root of x. All right. First what? X to the power 47 Rahul, into 1 by 2, correct? Divided by x to the power 1 by 2, correct? Next step, x to the power 47 by 2 divided by x to the power 1 by 2. Bases are same, x, and it's division. So we have to subtract the powers. So x to the power 47 by 2 minus 1 by 2. So it is x to the power 47 minus 1 by 2, LCM. So it's x to the power 46 by 2. So what's 46 by 2? 23. So x to the power 23. So this one is nothing but x to the power 23. This one, it looks so complicated, but the value of this one is the same as x to the power 23. So it is a monomial of degree 23. All right? Sure? So when I share all this with you, it's not blind copy, meaning it should not be blind copying. You need to, go through, understand, and then write it out. This you can help yourself. We're not discussing this now. You know how to identify if the expression is a polynomial or not a polynomial, and you also know how to identify the degree. That's the heading. Which of the following expressions are polynomials? In case of a polynomial, yes, only if it's a polynomial you can write its degree. It should be a polynomial, then only you can write its degree. If it's not a polynomial, you cannot write its degree. Degree is associated only for polynomials, not for algebraic expressions. Okay. Yeah. If it's a polynomial, write the degree. If it's not a polynomial, there is nothing like degree. For an algebraic expression, there is nothing like a degree of an algebraic expression. It's degree of a polynomial. Then here you know. Rahul, you're not looking at the board. Are you seeing the reflection of the board on the ground? Yeah, then how are you falling without looking at the board? Huh? Thinking what? Thinking beyond what I'm saying, huh? Okay. And here you'll have to classify as linear, quadratic, or cubic. All right. This also is familiar. You can help yourself. Put a tick mark if it's a polynomial and a cross if it is not a polynomial. You can do this. So I'll be sharing this with you. You don't work this at home. I'll share this with you. Just go through the questions and come prepared for the class. So we'll be doing this in the class. But you can just have a look at the questions and prepare, mentally as to how to answer in the class here. So this I'll share, but you don't have to complete. Don't write the question also. This slide will be shared with you on WhatsApp. Just have a look at the questions and leave it. That's it. You don't have to even write the questions. We'll do it in the next class. All right. Okay. Any questions?
No questions, ma'am.
Lakshana and Harsha, any questions?
No, ma'am.
Okay. Here, children. Okay. Answer this one. Identify the non-negative integers here. Identify all non-negative integers? Simple question. Because we have 3 more minutes. Very simple question. See, I have given you a list of numbers here. So from this list, I want you to identify all the non-negative. There may be only one or more than one. The heading is identify all the non-negative integers. Yeah. Is minus 4 by 7 a non-negative integer? What about plus 4 by 7? Is it non-negative? Is it a non-negative integer? No. See? No. 4 by 7 is not an integer. What are integers? 4 by 7 is not an integer. Okay, that's all. Integers are what? 0, 1, 2, 3. This collection. Minus 3, minus 2, minus 1, 0, 1, 2, 3. Goes endlessly. Starts from, we don't know where. And it goes on endlessly. These numbers form the collection of integers. Where is 4 by 7 in this list? Okay. So is this one a non-negative integer? No. Is 3 a non-negative integer? Yes. See, is it non-negative? Yes, it's not negative. It's not negative. That's one thing. Is it an integer? Yeah, it is an integer. So it satisfies both. It's non-negative and it is an integer. So it is a non-negative integer. 3 is plus 3, right? So it's non-negative. And 3 is an integer. Non-negative integer. Yes. 0? Yes. Is it is 0 an integer? Yes. And is it non-negative? Yes. 0 is neither negative nor positive. Okay, it's neither negative nor positive. Here, when we say non-negative, it is not negative. It's not negative. The question is it negative? No, it's not negative. Is it an integer? Yes. So it's a non-negative integer. What about root 5? Root 5 is not an integer. It's positive, but it's not an integer. It should satisfy both the conditions. It should be a non-negative integer. It should be an integer. It should be non-negative. 2.6. Rahul. 2.6. No, because it's not an integer. It's positive, but it's not an integer. What about minus 5? No, because it's negative. What about 12? Because it's non-negative. And also it's an integer. So yes. So 3 from this list, 3, 0, and 12 are non-negative integers. They're all integers and they're all non-negative. So they're non-negative integers. All right. All right, children. So that's it for today's session. Thank you so much. See you. Good night. Online children, thank you. You may leave the call.
Thank you, ma'am.
Thank you, children. Thank you.